So welcome to Linux Fest Northwest, the last part of the day. My name is Brian Hatch. I'm the Director of IT at Extra Networks, which is placed down in Seattle. Before that, I was at a somewhat large search company that has places all over. Before that, F5 Networks. Before that, I worked at large browser manufacturers that got bought by AOL back in the day. I've worked at big banks. I've worked at lots of stuff, and throughout all of that, what I've been doing is keeping the lights on, occasionally breaking the lights, and getting the lights back up on again, and trying to get new stuff out there, getting new features working for everybody. I've done solo, I've done contracting, I've managed teams, and I have done everything wrong you possibly can have done wrong. So hopefully I've got a little bit of authority on what can be done poorly. Who should be here? If you're interested in patent litigation, Deb's talk I think is over there. We are always scheduled opposite each other. Her stuff is awesome. I won't fault you if you guys want to take off. People want to make new mistakes. I've made a bunch of them, so it's not interesting if you do the ones I've already done. Do something new and inventive and learn from it. If you want to know the difference between an SLA and the TSA, this class is for you. And for those who don't want to see code in presentations, this is something new. Normally, I'm like 900% code. This time, that's not the case. That didn't last long. In case anyone wants to know, regular expression, anchored at the beginning, anchored at the end. It'll match anything that has a J through the letter M, followed by a single character, followed by ED, or the letter I, thus, yeah, I lied. I love code. I love code. I live, I breathe code. So we're going to start off with a real event that I had in my history. And I'm not going to say when that history was. Just let's say that I'm not working with any of these folks today. The people I work with, we've all made these mistakes. There are going to be people in this room who figure out where I'm going. That's great. Try to let everyone else wonder for a while. I know you could just blurt it out, but it'll be more fun to watch the pain and agony that I and a team went through to figure out this problem. So we get a call from our production monitoring. Our production monitor is a guy named Owen. It'd be really nice if we had automated systems that caught this, but we'll get to that. So we get a call from a guy who's like, all of the stuff coming out of the website is broken. It's all blank. There's nothing in it whatsoever. Start at 5:23. So we're like, okay, let's go start digging around. Of course, he tells us this hours later. So it's been down for hours and hours and hours at this point. So, okay, 5:23 is when it broke. We're going to start looking through. So the first thing we do is go to the logs. Apache logs, if you're not familiar with what an Apache log looks like, the first column there is the date time. Note the utter lack of a year. Wouldn't that be useful? Then you have the time. The method, in this case, get, means get me a web page. The next part is the portion of the URL, what version of protocol it is. It should be 1.1, almost always the case. The next one there, that's the HTTP return code, the status code sent back to the browser. 200 means okay. You like 200s. That means everything went well. There are a bunch of codes that don't mean things are bad. Like 301 and 302 mean the content's actually somewhere else. Go look there. It's a redirect. 304 means it's the same as you had it last time. You don't need to bother downloading the whole thing. So lots and lots of static codes. 300s might be good, might be bad, depends. 200s are great. 404s, not found. 500s, some sort of server error. So you've got that column right there tells you everything you need to know, was this successful or not. The next column there, that's the amount of bytes sent back to the browser. So each one of these, we got 40,000, 70,000 bytes being sent back to the browser. This is stuff looking good. At 5:23, which is when he said everything broke. So I'm confused. And I looked through the logs around that time for a while, and I don't get anything very useful. Oh, shoot, that's right. He's in Eastern time. The server's in Central time. Okay, so his 5:23 in the morning is actually 4:23 in the morning. So I go to 4:23. Again, 200s, content being sent back. There's nothing wrong here. Website's still down. But what's going wrong here? I already see some people like, I know what's happening. Don't say it. Don't say it. Shut up. So now I'm looking at the right logs. But the local clock was screwed up. Okay, so I type date, on the server, and I type date on my desktop, and I do math. I hate doing math when shit's broke. Okay, so now I've done the math, and I forgot it's 2 a.m. Okay, now I'm looking at the right logs. Really, I'm looking at the right logs. 200s, and content. Okay, what's wrong now? Don't say it. What's wrong this time? I don't know yet. I have an idea. Let me go and actually look through the logs rather than just my eyeballs. Let's use some tools here for a second. Okay, I'm going to use awk. I know there was a session earlier that said you never should use awk. This is the only thing you should ever use awk for. If you learn one awk pattern, this is the one. If you know any other ones, I apologize. Awk print column 7, column 2, and column 4. So go through this, grab those columns based on white space. Don't do anything fancy. So we're going to print out column 7, I believe, is the return code, which is 200s. Number 2 is the time, and 4 is the URL. So in this case, it would be thing 0. Sort those numerically so I can just see what I've got. Actually, I think we're sorting by, 7 is the number of bytes. Okay, so I see number of bytes is 0. There's a bunch of stuff with 0 that happens at 2 in the morning. There's a bunch of stuff with actual sizes happening at 2 in the morning. So we've got some that are 0, some that are not. So now I'm confused because I could have sworn I was looking at 2 o'clock and 2 o'clock had no problems. So I don't know what's wrong. Okay, I'm going to keep looking. So let's just go and start grepping through it. So find me all the stuff on the 6th of November at 2 in the morning that was thing 3 that had a size of 0. There are 29 of them. WC means just count the lines. There are 29 things at 2 a.m. There were zeros for thing 3. And looking a little further, let's do the same thing and just show me the first one. The first one happened at 4 seconds past 2 a.m. Okay, that's a 0. I could have sworn I didn't see that when I was looking before. Okay, let's look a little longer. Let's show all of the ones. Let's not worry if they were size 0. So show me all of them, and I see that the first thing that I had was let's see, I'm going to pipe ahead. So just the very first one, the size was 78K, and it was at 42 seconds past the hour. Okay. How is it the first thing in the results is at 42 seconds past the hour, but the first thing that had 0 bytes happened 30-some seconds earlier? Now I give up, man. Even my tooling isn't helping. I start looking at the logs line by line by line by line. And I see, okay, things are just fine. Thing 3, I'm looking at carts. I got stuff coming through. And then a minute later, it's 2 o'clock in the morning again. Who likes daylight savings time? If you're in computers, you don't like daylight savings time. Why should my clock switch by an hour? Especially, why should it go backward in time? What a wonderful thing I've discovered. So, in fact, what happened is, as I was eyeballing things and I was searching within to find exactly where I wanted to go, I might have found the first occasion at 2 in the morning, or I might have found the later occasion at 2 in the morning. All of those logs were in there. It was fine for the first 2 a.m., all the way up till 2:59 p.m., and then when it became 2 in the morning again, something broke. So, daylight savings time, bad. Okay, so I told you the reason I found this out was my production monitoring. A guy named Owen gave me a call. Why didn't my normal monitoring catch this? Well, there are a number of things in this failstorm that were causing that. So, first one is we were using standard Nagios. Anyone here use Nagios or any of the variants of it? I think all those things. It's one of the worst monitoring systems out there, other than all the other ones. They all suck in one way or another. This is the one that's been out there the longest. It's one of those things that is very well known. If you have suffered enough with the config to learn it, to you it feels like it makes sense. And so when the next person starts in your team and you say, well, clearly you do it this way, and they look at you like you're from Mars, they're actually the right ones. And you just got to realize that, well, every monitor is a little bit different. This is one that's out there. We all use it at some point or another. So it has a thing called plugins, lots of different plugins. They're usually command line arguments. And this one's called check HTTP. It goes out, does an HTTP call, figures out what's the return code, is there SSL, all sorts of different options you can throw at it. And we were just simply saying, go out to the website, example.com, pull it down, and the check HTTP wants to see, is the return code 200? The answer is yes. The return code was 200. We were sending back 0 bytes worth of content, so the browser actually showed nothing in there, but from Nagiyo's standpoint, the web server was providing back exactly what it thought it was supposed to. So our production monitoring was completely blind to this problem. Luckily, we happen to have some Wireshark or some TCP dump running from a different issue previously. It was capturing traffic and about every hour just rewriting new packet files. So we were dumping all the traffic on our web servers, both in and out, to disk. And as happens so often for me, I resort to ignoring my logs, which clearly were confusing the heck out of me anyway, and resorting to packet captures. So I pulled up my good old trusty Wireshark and I started digging around in this packet capture that happened to be on disk to figure out what the heck was happening at the time. So in this case, we had so many separate pieces of fail. We had a monitor that was just checking to see if it was a 200. It didn't grep to see if there was a title, welcome to exampleco.com or something. The backend database turned out to be the thing that was actually broken. So at 2 a.m. the second time, some cron job that the SQL administrator ran saw the time get screwed up and decided to just kind of delete all the records. Well, because time never goes backwards. That's crazy talk. There was some logic about, if this is older than that, then do this, else, clean up. You must be in development. Who knows what it was? Oops. So the web server is making queries back to the database. The database says, I got nothing for you. And the web server's like, hey, great. My application layer says, send back nothing. So that was one of the problems. The application should have handled that correctly. It should have said, if there are no results, maybe that's actually not so good. Maybe instead of sending back a 200, it should have sent back a 500 error of some kind so that my monitoring would have caught it. So plenty of things that were broken. And once we found out that this is broken, we had what we call a post-mortem. You get everybody in the room. You sit down and say, we all were at fault or not. It doesn't even matter. We don't care about that. We want to make a good, solid production environment. What do we do together to fix that? What were the problems that happened and when? And you literally go and say, at this time I got a call from Owen, at this time I looked at this, at this time I looked at that. Everybody in the room with no blame, and that's critical, owns up to everything that they saw and everything that didn't work. You make a list of it and you fix them. So the next time we had daylight savings time, it wasn't an issue, and we did some simulations of daylight savings time happening after we restored the production website. So takeaways. Use NTP to synchronize your time. I don't want my machine off by 2.5 hours. That's just ridiculous. Use UTC. Yeah. Now, you sit down at your desktop and you say date, and you don't want to know what the time is in London. You really don't. But on your servers, at least, please, dear God, just use UTC, because the time doesn't go backwards and forwards. The time on the server here in Seattle, here in Bellingham, here in the UK, somewhere in Germany, all of them are going to agree on the time. And so when you're looking at your logs, the logs all agree on when something happened. You don't have to do any math. Well, I know the UK's daylight savings time is 2 weeks after ours, except that year it was a little bit earlier, and you're starting to look at legislation to figure out what time something was. It just does not work. Just use UTC. Better monitoring. There's always good uses of better monitoring. Off-box your logs. So in this case, I was literally running awks and seds and VIs and lesses on the machines. I didn't have any good way of looking at this logging information. Get that stuff off box, especially if you have multiple web servers and you want to look at all of it at once. At least put it on a single server where you can use shell commands. Better yet, put it in like an elk stack or something where you can get some decent tools to visualize it. Serving errors. It's really, really fast. If your monitoring involves saying how fast did some content get served, the fastest thing you can serve is nothing. So be a little wary of that. If that's the only metric you're looking at, watch out. I've had places where I could serve up 0 bytes, lickety split. Our SLA looked great, except it was all bad. Never 200 for errors. When you're writing your application, if there's an error, you can still present a nice, pretty error screen to the end user that says, we're sorry, we're down for scheduled maintenance, haha, or a fail whale, or whatever it is you want. You can have an error message come out that looks pretty to the end user, but when you send it, you can send back a 500 error instead. So the monitoring system can actually know for a fact that it was a problem, even though you don't make it look so nasty to an end user. Nobody likes to see the generic web server down in their browser, but you still can send an error response that looks pretty to end users. Wire data. This is a term, and I apologize, this is related to the place I work. I love packets. I love being able to see what actually happened on the network. The only reason we solved this one is by looking at that stuff in Wireshark. My logs were hopelessly screwed up, and I was constantly doing new math on it. Being able to look at what actually happens on the wire, getting that data is hugely valuable because it's what actually happened regardless of what the rest of my systems told me. So logs lie. If anyone else doesn't believe that, you haven't been bitten enough. Your logs always lie. One of the biggest problems is you can only log the things you think about ahead of time. If I know that this problem could come up, then I write a log around it. If I don't know about it, I don't, until we have an issue, and then later on, we go back, we add those logs later. So your logs do get better over time, but they never have enough data, or in some cases they have so much data I can't even look at it all. It's hard to correlate your logs. You've got your front-end web server, you got your load balancer in front of that, you got an application tier, you got database, you got all these things. And trying to correlate those logs is really actually kind of tricky. I'm much more of a fan of getting multiple sources to find out what happened in a system. So if I've got my logs, plus my wire data, plus Owen, thank God for Owen, all those things, you add it together, you get a better holistic picture of what's happening in the world. Examples of bad logs. I've seen a lot of cases where people try to time things. It took this long for me to read the file off disk and send it back out. And they might do a timestamp of when the transaction started, and then get the time when they send the first byte back. And that might be really fast. But the time between sending the first byte back and sending the rest of it could take 5 minutes or 2 hours. Or it could be that you hand it off to the kernel sees the write, and it's going to send it out, but the network is really, really slow right now. So it's okay. Linux has got the whole file cached in memory, and it's going to send it out as TCP allows. But you don't know that it actually took it 5 minutes to get those 25 characters across the network. There's a lot of stuff you just don't have visibility to, no matter how well you write your code. And of course, one of my personal pet peeves, date formats. What is the right date format? And I have only one answer for this. Anyone want to bet?
ISO formats, which is year, month, date.
Why would I want?
ISO 8601.
Why would I want year, month, day?
Sorting.
Oh my God! It's the best thing ever. If I could just sort, and you got the big thing at the front, and it gets smaller. What about 17/April? How do you sort that? That does not help me. There's only one way to sort, or one way to write dates, and that is to use the ISO date format: year, month, day. Please, dear God. And there will never be a 5-digit year. We don't have to worry about that. At least I won't be here.
Some of us might.
So let's talk about on-call. You carry the pager. You're the one who gets that call. Hopefully it's from your monitoring system, so not from Owen, but if your monitoring fails, Owen calls you. This is not something I found on the internet. This I actually found on the whiteboard with one of the people who works with me. This is William's will to live meter. And he would update it once some things on call got nasty. The things that were going broken in prod were written, unfortunately, by yours truly. So you're feeling really bad. So there was a thing that worked great for a small amount of data, and it got worse over time as the stuff was bigger. So we were getting pages. And I really want people to have a will to live. So on-call should never make you feel like you need to put a doomsday clock on your wall or the will to live. So how do you get there? So let's talk about alerting. In my opinion, there are only 3 things you do that alert you. And this could be coming from your monitoring or whatever it is. Maybe even your application is sending you alerts. But there are only 3 things that should be happening. 1, they should send a page. It should send a page if you gotta do something. Not if, hey, it'd be nice to know. And I actually go in a little bit more detail in a moment. Pages are the first thing. Tickets. If you got a ticketing system, that's a great way to manage your work, as well as things that happen in production. There are many open source tools, there are many payware tools out there for ticketing. Most of them have some way, either via an API or sending an email into it, to turn information into a ticket. And so first thing you do, you walk in on Monday morning, you look through your tickets. You figure out what stuff was not broken, but needs to be looked at. So those tickets tell you things that weren't mission critical, but would become problems later on. And lastly, logs. Some people spell log E-M-A-I-L. If you want to, that's actually fine. You can just send all your logging related information into an email, you put it in a group, and you look through it. In my opinion, those first two are things you look at, and that last one you don't. I don't look at my logs except to help me figure out how to address the pages or how to work on the tickets. If you have to look at your logs in order to know if something was working or not, you've got the system wrong. You should intentionally never look at logs except when you have something that's currently broken. Your monitoring should say you're running out of space, rather than you go and look at your logs to see if you're running out of space. If you have to go and query something, you have to go and research something, then you could have automated that. You could have made it so something told you it's time to look at this process, this server, this database, this disk space, this CPU. Have something reach out to you. Use your brain for more interesting things. So don't look at your logs, except to solve the first two problems. So let's talk about what's actually page-worthy. Pages come, they wake you up in the middle of the night. The pager does not realize if you're asleep or if you're awake. That little thing just goes off. Most of us, I think these days, just use our phones for our pagers. They're next to your bed. Your significant other hears them go off at 3 in the morning. She really doesn't like it. If it's really bad, she says, you were never going to have that ringtone again. You say, yes, you are right. I will change it. I've had that happen 3 times where I'm not allowed to use that ringtone anymore. Bri had a will to live meter toward the red side. Those pages need to go to the right person. If I receive a page and I do not have the ability to fix it, I don't have root on that box, I don't have access to that system, that page should never have come to me. If all I'm doing is calling other people, make your system better. Make the system reach to the correct person who can fix the problem. It has to be time critical. If the thing that is paging me right now could be done on Thursday, then it should not wake me at 3 in the morning. If I don't need to take action right now, if I don't feel like something's broken and action is required, I have to go jump up, I'm willing to have that adrenaline, it is not a page. Has to be actionable. This is not information. This is a directive. Your system is saying something is broken or something is about to fall over unless you, the human, does something. It needs to require a person who knows how to fix something that you couldn't have anticipated. So it needs human intelligence. It needs somebody who knows how the system works. They know the architecture, whatever it is, requires a being to walk in and do something. So it can't be something that could have just been scripted and fixed on its own. If you write a self-healing system, the system always at 3 a.m. has a problem. Well, why don't you just have something automatically fix the problem at 3 a.m., especially if you're always doing the same thing. Lastly, there should be an escalation path. If I get a page and I don't do anything on it, it has to go to somebody else. Because if it doesn't, and no one minds and that's okay, then it wasn't required to get to me in the first place either. So if you wouldn't say, this page goes first to person 1, if they don't respond, it goes to person 2, if they don't respond, it goes to person 3, if you don't say that that's important, it was not worth paging you. Sleep is important. So, here's some things. If you ever say these when you get a page, you know that it shouldn't have been a page. I can just go to lunch first. And it always happens this time of day. I am really not a fan of the page that happens at noon to make sure the pager works. Who has been at a place where always at noon or some random time the pager goes off just to verify that the pager works? Do you remember if the page didn't happen? Of course not. Yeah, it typically clears itself up. Well, maybe you should automate it so it gets fixed on its own. Yeah, I just run this script and it's all good. Well, maybe you should have that script run automatically. Only so-and-so can fix this one. Well, then page so-and-so, not me. I'm not the nanny who's going to get that person.
There's one missing. My users will notify me in 10 milliseconds if the internet's down.
I'm sorry, say that again?
My end users will notify me in 10 milliseconds if the internet's down.
I don't think I've ever had a user notify me in 10 milliseconds. You've got some really fast users.
I'm exaggerating for effect, but it's pretty quick.
Yep. Okay, so when it comes to alerting, what should you base it on? You should base alerts on something is known to be in a bad config, like you're getting 500s instead of 200s. There's a known bad. You should notify in percentages. I'm actually much more of a fan of percentage-based alerting than threshold-based. If I say no 404s above 200 per second, well, what if I've got that great slash dot effect? Does anyone still say slash dot effect? You got a huge traffic spike, and suddenly you've got a lot more traffic than before. Well, then your errors are going to be proportionally higher than they were before, just like your normal traffic is higher. So I really am not a fan of basing things on thresholds. So instead say error ratio, so the number of errors per success. Base your measurements and your alerts on that kind of information, and then when you have traffic spikes or traffic dips, it still works. So based on percentages, based on trends is another one. If you can get trending in your system, a Friday afternoon at 3 p.m. typically looks like this, but today it looks different. That gets screwed up a little bit when you have holidays on Mondays or Fridays, but overall trending based on what it looked like that time of day, the previous week, the previous month, can be a very good way of saying this looks not normal now. And rapid changes. If you see a huge delta in something, either up or down, that might be worthy of note. I'm very much not a fan of thresholds unless there is a really clear reason the threshold makes sense. If you got a 1 gig pipe to the internet, yeah, you can page on 99% of that. That is simply a threshold. That's good. But if you don't have some artificial bound, I don't like threshold alerting. Partial impairment. If I got a website, got a load balancer, it's got 25 machines behind it, don't page that one's down. Page when the system is having problems, not when one of the machines is having problems, but the system is still healthy. You send a ticket for that. Dear human, when you wake up in the morning, figure out why web server 05 is having issues. Partial impairment, build it so it can handle it, and then don't let me know, don't page me. So let's talk SLAs. SLA is something that's actually built off of 2 other pieces. The SLI and the SLO. A service level indicator, service level objective, and service level agreement. A service level indicator, that's something you can measure. If you cannot measure it, you cannot alert on it. You can't know what it is. 200s, how many are there per second, per month, per year, whatever. You have something you can actually measure, something that you can say it's above or below a threshold. The above or below a threshold is the SLO, the objective. I want to have errors at 2% of my total traffic. And I know that the internet is filled with people with annoying browsers that sometimes screw up, or they go to broken links. So I'm going to have 1% 404s. I'll consider that okay. You should allow for not perfectness in the world. So have some sort of value of that to measure.
Is an SLI the same thing as a KPI?
A key performance indicator, KPI, you can use that term if you want to. I usually see KPI when you're talking about OKRs, objectives and key results. So now we're getting kind of management-y. So SLI, SLO, you add those together, you make an SLA. An SLA is an incentive to meet the objective you've got. This is usually carrot or stick or dollar signs. If I don't make my SLA, I promise you, my customer, to not charge you next month. Or I will charge you 10% less next month. So some sort of carrot or stick to make me meet that goal. So that's what the SLA is. So look at some of the standard ones. You've probably heard of a number of 9s. So this is usually a measure of uptime. And how you measure uptime, we'll talk about in a couple slides. So you might hear 2 9s, 3 9s, 5 9s. Those 9s, when you're talking about uptime, is the percentage of the overall time that this is being met. So if you're talking about just straight uptime for a website, 99%, so 2 9s, that means more than 3 days a year you could be down about 7 hours a month. 4 nines is 56 minutes a year. Not very much in comparison. Only 4 minutes a month. 5 nines. You hear about places making 5 nines. That's 30 seconds a month of downtime. Now, these things you can make. You can make every single one of these if you wish. The trade-off is dollars. If you have more people, more infrastructure, multiple data centers, you can absolutely achieve all of these if you have enough time and enough dollars spent on both your engineering talent, your infrastructure, your redundancy. You can get 5 nines if you want to. Now, it might be prohibitively costly to get 5. You might think 4 makes more sense. Maybe even 3. So this is the downtime you're saying you're allowing. Now, 5 nines sounds sexy, and what you have to do is you have to work with your customers, your management, whatever, to decide what you want to make. I think 5 nines is nice, but even better is 9 fives. Now, if you get 9 fives, you're allowed 162 days of downtime. And if management doesn't realize what you said, then you can probably run your entire infrastructure on a Raspberry Pi, take off on weekends, weekdays. So try for 9 fives if you can. You probably won't make it, and if you do, you're probably working the wrong place. So example objectives you might have are not just uptime, because you have to define what uptime means. So you might say, we're going to serve a certain percentage of our traffic under some other number of milliseconds. So 99% of our traffic is going to be served in 5 milliseconds, 10 milliseconds, 1 second. So you've got to be clear about what you're actually measuring and have the ability to measure it. Error ratios. We'll have an error ratio of 2% or less. I've seen places where you have to have different buckets for different kinds of things. Like a place that was just doing nothing but file serving. Well, you don't want to have the same SLA for a 2 gigabyte file as you do for a 25 meg file. So you say, okay, small files are defined as this. Those will be under 5, half a second. Medium ones are under 1 second, and large under 3. So come up with things you can measure that make sense for the business. Here are some ones I've seen also, which are more interesting. Never down for more than 5 consecutive minutes in a 1 hour window. So you could be down for 5 minutes every hour. That's not very good. Less than 1 or 0.1% unscheduled downtime. So I can schedule to be off during January. Can't fault me for that one. I don't have to pay any money. My personal favorite, this is what I see usually for like SMS messaging. Messages are guaranteed to be delivered no more than 72 hours after being sent. We promise if we manage to get it to you, it won't be 3 days later. But we don't say we're going to get it to you in 3 days. But we promise you we will definitely not even try after 3 days. When investigating paging technologies, this is important. We've got one guy who's currently getting pages from something still on Thursday. I'm like, I'm really sorry, Kevin. So what is an SLA? We've been talking about the fact it's some sort of agreement, some sort of contract between you and your customers, your management. Turn it on its head. This is not something that you need to meet. This is playtime. The SLA says what you have to have achieved in order to have success, in order to have met that goal. But that also means, on the other way, is the time that it's down is defined. The time you're allowed to have the service not up and running. That is the place that you can be aggressive of how you do your work. Let's say I want to push a new version of the code out, and I know it's got a potential to take down the website. I know if I screw it up, it'll take me 20 minutes to revert back to the old code. So I could spend 3 weeks running multiple simulations in dev, create an entire dev environment that looks perfectly the same, run many iterations with production data, backport it all in there, and figure out exactly what we can do to make sure that there's no downtime. But if I know for a fact that I can have it down for 20 minutes, that's part of my SLA. And I know that I could easily roll back. And 20 minutes of downtime this month is in my SLA. You know what you should do? You should push the button. And if it breaks, what do you do? Say, well, I guess it broke. Let's hit the revert button. And you're back in 20 minutes. You just saved 3 weeks of time testing your rollout. You should play fast and loose when you are within your SLA. You should be aggressive. You should aim for failing fast. Have that rollback method. Know how to revert back to something that worked. But play, move forward, break it, It's okay. You've been given a license to do so with very specific achievable metrics. Do it. Break the website. Maybe try it late at night. Okay, so when the SLA is not met, so you played fast and loose and things didn't break, or things broke, or maybe you weren't playing fast and loose and stuff just was not working anymore, you've got to fix it. You've got to fix the system. You've got to make sure that will to live meter is not back in there in the red again. So some things you can do, you can dedicate a person to improving the system. Take someone in your team, say your job is to start trying to fix it. Figure out the root cause, make it so it doesn't happen again. Other things I like to do, especially more of a DevOps environment, all features are off the table. All we're doing now is we're working on system health, system stability. So if you have a new feature that you're 90% done with, that's great. You can finish writing it, but we can't push it. Not until the system's healthy again. That's a good incentivizer. Even better is give them the pages of the devs. Oh, you think it's no big deal, huh? Here's the pager. I hope you sleep well. That one seems to be the most successful, honestly, at getting the system to be stable. You also have to watch out in those cases that they don't just fix, quote, fix the monitoring. We're all guilty of that one. Well, it said 5 seconds, but I changed it to 50. As long as your SLA is still met, you're okay. But if you're making your monitoring not actually enforce your SLA, you're in trouble. So we actually had to go through some of this with that code written by me in order to make production not paged multiple times at 3 a.m. And this is what I came into the next day. The will to live meter had broken through the green, and I was very happy, as was he. So on-call doesn't have to be bad. Oh, looks like a Duke page. Tools for on-call. You should have monitors that do not alert you in any way. You should have monitors that are checking the health of each one of the web servers, but those don't necessarily page you. But when I'm trying to troubleshoot something during on-call, when there's actually a problem, seeing additional data is very useful. So by all means, monitor stuff that never pages or perhaps never even logs or never sends tickets. Do monitor all the things. Monitor all the things. And because that, having all the greens and reds on that monitoring page will have you a better idea what's causing the root issue. So monitor things even if they're not necessarily paging. Documentation. Who here is really good at documentation? I see 0 hands, and the ones I see are upper line. All of us should do more documentation. Think of when you're writing the stuff, you write the documentation. Write it for somebody who would want to call you angrily at 3 a.m. That's your audience. Don't make it great for the CEO to read. That's not who needs to read it. It's the person who's trying to fix the thing at 3 a.m. so they don't call you. That's the level of detail you need. On-call playbook, that's often documentation as well. Specific things to do if you see the specific problem. Jumpstart their remediation steps. And then lastly, call trees. This service is run by this person. This is the lead of that group. There's their phone number if you can't solve it yourself. Monitoring is an ongoing process. You're never done. It's just like security. You're never done with security. You're never done with monitoring. You're never done writing your code. It's always getting better. So I'm going to go over this quickly because I don't want to go in quite so much details about the logs. We had a problem. We've figured out we want to have better monitoring, so we used check HTTP part of Nagios. But it only showed like specific pages that were up or down. And we wanted to be able to have something a little more robust. If they go to the cart and then go to this page and then go to that page, well, we couldn't capture that. We were just looking through individual pages. Does this page show whatever the product was? Yes or no? We wanted to see some flows. So we said, okay, well, let's use this cool thing in Perl. I know I don't use Perl anymore. Called www.mechanize, where you could actually say in Perl code, quote, click on this page. It gets cookies, all that stuff. Then click on this page and click on this page. Look on that page to make sure you see the right price. So we did some automation to try clicking through as if we were a browser to test more than just a single thing. That's great. The problem was that was never kept in sync with the product. So every time we launched the product, all the alerts fired because the flow was different. So we're like, okay, well, that's not so good. So what we'll do is we'll do a self-check on the server. We took that check, and instead of having Nagios call this check that did a bunch of stuff, we put the check on the web server itself. You called a special URL on the web server. It checked itself. And so that way the check was with the code. So if you're writing the code, before you can push it to prod, the checks had to pass. If they didn't, you knew who would cause a problem. You just revert back. So now when you push the code, you're also pushing the monitoring. Oh, it was great. Unfortunately, this test took a long time, and so our load balancers thought that all of the checks were failing because it was looking for a 5-second response. And this was very robust. So, okay, let's break that into a quick one for the load balancer and slower ones for the full-blown test. So we had /fast health and /full health. Fast health for the load balancer. Does this thing look like it patches up or not? Very lightweight. Does it see that there's a database but don't actually do any calls to it? So that was great. Felt like we were in the perfect spot. We slowly rolled it out to all the other web properties. Took a while. Unfortunately, the URL looked the same for everybody, so we didn't know for sure that we were testing the right thing. So somebody made a misconfiguration of the load balancer pool and put 3 of the cart web servers and 2 of the documentation web servers in the same pool. And it happily saw that the fast check was passing. So now we were serving up 2/3 of one content and 1/3 of different content. That didn't work so well. So we appended a cite part in there too. So, hi, I'm the load balancer. I'm expecting that you're dub. Please do a full check or do a fast check. And he would say, I'm not dub. You are confused. And so the load balancer would not let that stay in the pool. So close to the end of my mantras here on monitoring. Catch the things you don't know about. All this has been talking about finding things you know. Mind you, of course, Owen always finds the things you don't know. RUM, real user monitoring. This is actually a great thing to figure out what things look like from a customer perspective. I think I served a file in 5 seconds, but my real user monitoring, which is essentially browsers reporting back stats to you, says that the pages are 30 seconds, 50 seconds, 80 seconds. You can get lots of cool information by having the customer browsers out there send you data back that you can analyze. Trending, I think I mentioned that before. Wire data, where I find all of my info. Angry users. Poor dear God, Owen. Okay, so let's talk about monitoring the right things. This is another recent case. Oh, I mentioned the ugliness that is Nagios. Here's Nagios. So I wanted to simply check to see if our apt caching machine was working, because I want to make sure it's up and running, because all of our machines talk to it, because it caches the app packages. We don't have to worry about everybody downloading stuff from the internet directly. So we've got this horrendous syntax. We have a command called HTTP port grep header. So it's an HTTP check with a specific port passed, thing you want to grep out from the header. So Nagios is going to replace arg1s and arg2s in this output. I'm not even going to go into it. It's horrendous. I apologize if you understand what this means. So here's our check. We want to check port 3142. It's our standard cache. We're going to search to see that ACNG report is in the output. And who are we going to check? We're going to check the VM103. That's the machine in the data center that runs the app cacher. Here's its address. It's 192.168.253.288. Clearly I made that number up. And so he's an app cacher NG group, so he's automatically going to get checked. So what could possibly go wrong? Any ideas? This is all valid. It's just wrong. We were monitoring an IP address, but then we moved that service to some other machine. Now, the old machine was still up and running, and it was being monitored, and the machine no one was talking to was still working, but we actually had a CNAME that pointed to the real thing. Maybe we called it apt or proxy or something. You should use DNS in your monitors. Now, you're going to read stuff that says, don't use DNS in your monitoring. It slows it down. If your DNS is so slow, you have a different problem. If you're monitoring, trying to use DNS, can't figure out the DNS addresses of something, then what you should be raising alert of is DNS is slow. Buy more DNS servers.
You do subject yourself to a single point of failure.
Set up dependencies. If you've got things that are dependent on each other, like let's say everything's in a remote data center, you can say, check this VPN endpoint. If he's not up, then everything in the remote data center is down. Don't even bother paging me on this. Have everything depend on the DNS is healthy. Because otherwise, you'll get exactly what he was mentioning. When DNS breaks, you get all the alerts. Because everything is dead. And your phone is going, and it runs out of batteries because it vibrates. I have had a phone run out of batteries on call when it was fresh when I started the service.
They get escalated to somebody else and their battery dies.
And their battery dies. And you get the pages for 3 days, but not more than 3 days.
The right mix I found specific use of this is to use DNS for servers
that also works. So I'm going to repeat things, by the way, because we're being recorded. Using IPs for network infrastructure, often the case, and then DNS, CNAME specifically for servers when it makes sense. Another thing I've seen done is take your monitoring server and make it a replica of your DNS server. So it gets the exact same records as everything else. As long as you're monitoring, it gets the updates. Okay, backups. I wasn't even going to put this on here. Do we all think backups are important? Yes. Where do you put them? Do you put them local? Do you put them on a remote server via rsync? Do you put them in the cloud? The answer is yes. Put them everywhere. Just know which one is of what date so you can use it for a restore. But put them all the places. Disk is cheap. Remote stuff is cheap. You can have the servers in the same data center. You have a USB drive you take home. You can send off with Iron Mountain, whatever it is. Yeah, back them up with all the things. Never underestimate the bandwidth of a pack of emus. Seriously, this is something we said at a place I worked. Physical media is really dense. You don't have to transfer it over the wire. You just bring it home, ship it to the other place. Been places where in order to transfer the data from one data center to another, it was faster just write it to a drive and send it through the mail. If you haven't restored, you're not backing up. If you have not tested a restore of your SQL server, if you've not reinstalled your web server from scratch, if you haven't done a DR test, you're not actually backing up. You might think you are. Do that before you're done with the production launch. Know how to do the restore. Test it. Okay, literally this morning, I've been getting texts from a person with whom I've done work in the past. This is literally what you're saying. The website's broken. These are his responses to my obvious questions. No, we turned off the local backups because we needed the space. Oh yeah, we turned off the remote rsync backups. It's broken for a while now. We don't know why. We didn't have the time to figure it out. Okay. Oh, the cloud backup stopped when we stopped paying for it. Fail, fail, fail. We're not done. Oh, we removed the old logs. We needed the space. Oh, and we turned off the new logs because they were slowing down the computer. And we didn't maintain that monitoring you wrote because it takes so much time to keep it current. Like we kept revving the product. And we never implemented any of the other monitoring systems that cost money. You know what's happening right now? They're losing money because the website is down. You could. I don't need to preach to the choir here. My phone is still getting pages from him today. And lastly, so can you figure out what's wrong? I believe my answer was, I'm at a conference all day. I'll talk to you later. I hope you're watching this. Testing. Won't go into this too much, but unit test, unit test, unit test, unit test, unit test. I love unit tests. The place that I learn unit tests the best is when I'm learning a new language, because I don't know how it works. So I figure out the unit testing language, I write a unit test, and then I start writing code in that language. And then I know for a fact when I'm done, this stuff works. One of the big things that I handed off to one of the other people, the Will to Live meter again, was the most highly unit tested piece of code in the company. And when he took over this code, I believe his first thoughts were, well, that's not Pythonic, and various other derogatory things that were well earned on my part. And as he went to make changes to make it look better, to do things in a better way, he could always tell if it worked or not. Not by running it a bunch in prod, but just by saying, do the unit test still pass? Make a couple changes, unit test work, good. Move on to the next one after a commit. Use good test data. I've had a lot of places where we have to test off of data. Where I'm right now, we're testing off of PCAPs. I've had places where we're doing API calls. There's lots of stuff you can do. You can only really test the things you think about. Throw lorem ipsum at it, that kind of stuff. I like to throw fuzzing at it. So instead of just sending known data, there are a lot of fuzzing tools out there that'll send data that's kind of like what you said. It might crash stuff. It's great when something you wrote crashes your code before something in the live crashes your code. So fuzzing is good. When you're looking for a random corpus, Shakespeare. I don't know why, but put all the contents of Shakespeare through your API or whatever it is you're running. That seems to always break it. As You Like It seems to be one of the best plays for that. One place I worked was trying to write a caching load balancer system, and they wanted to get lots and lots and lots of different client software, FTP server or FTP clients, HTTP clients, and trying to figure out how they can get a lab full of every single browser, every single FTP client known to man. They found a different way of solving that problem. They put up a site with some questionable content and mentioned it in a news group. And they had all the clients in the world. And they didn't have to pay a dime. So never underestimate the power of enticing content. Use your imagination. It was not My Little Pony. Maybe it was. Limiting yourself. Here's going to be something that sounds kind of counterintuitive. If I tell you to build a system and I give you no parameters at all, you pretty much feel lost at sea. When you limit things down, you actually make your life easier. At the place you work, limit the languages you use. We're a Python shop. Nope, you can't use Ruby. Okay, we're a Ruby shop. Nope, you can't use Python. Can't use limit down to a couple things. Maybe it's one compiled language and one scripting language. Everyone use the same things. Everyone just do that language. Even if you don't know it, learn it. You'll be able to have code reviews. You'll learn it better. It'll look good in your resume if you want it later on, but all of your code will be easier to read. So limit that down. Use rigid style guides. I don't care that your editor doesn't know how to do 4 spaces versus 2 versus 8. Figure it out. We probably wrote down how to do it. Don't use tabs. If you use tabs, you're dead to me. Pick what hypervisors or cloud you want. Don't have Azure and AWS and this and that. And, I want 4K VMs just on my desktop. No, just pick a couple. Try to limit things down so you can just get good at those. Code review, just live and breathe code review. It's so nice. I say this knowing I also violate that one. PM, by PM I mean project management. This is often anathema to engineers. They don't want to have tickets and projects and break it down into epics and stories and all that stuff. I don't know what a swim lane is. You know what? Get some project management. Get a person who can come in, who can help you organize your work, make sure you know what you're trying to do, know when you're done, so you can move on to the next thing. I cannot speak strongly enough about having project management skills where you are. And maybe that's a dedicated person who does that for you and helps you out. But getting everyone on the same page, especially when it's cross-functional, it's the only way to get stuff done without pulling out your hair saying, why didn't they get me what I needed when I needed it? Tools and infrastructure, pick just what you need. Don't have Git and Mercurial and SVN and. And if you still are running RCS, more power to you. If that's what you want, use it. That's great. I'm not working with you. Git's a great tool. Use Git. Don't pick everyone under the sun. Don't pick 5 different Git servers. Pick one Git server, put them all on the same spot. When it comes to tools, use them the way that they were designed to be used. The person who wrote the tool wrote it that way for a reason. That reason is valid because you are not smarter than the tool author. This person wrote the tool and it's out on the internet and tons of people are using it. Git. You know what? I'm not smarter than the person who wrote Git. I'm just not. So I should not try to make Git look like Subversion. I want auto-incrementing ID. You know what? They figured out that's actually not that useful. So just deal with it. So use Git the way it's meant to be. Don't make it constantly rebasing. You can if you want, but don't mandate it. Do merges. Merges are great. It's a wonderful thing. You're not smarter than the tool author. If you are smarter than the tool author, use something else. But if you're not smarter than the tool author, use it the way it was meant to be used. Don't try to turn it into something else. Okay, don't be clever. This is essentially me chastising me again. How much time do I have? 6 minutes. Yeah, we might get there. Okay, I'll try to go quickly. Longer but more readable code is better than shorter line noise. Perl. You're not smarter than your coworkers, and more importantly, you are not smarter than you were 6 months ago. Or 6 months hence. What I write now, if I can't read it in 6 months, and that happens a lot, then I did something really ingenious and bad. So let's look at an example. What does this guy do? Here's a shell script. I was transitioning a piece of system over to somebody else, and they find this. Set -e in a bash script means die instantly if there's an error. Great thing to have. Set -u means if there's a variable used that wasn't defined, die immediately. Catches bugs. So cd into the directory this file is run. Pull everything down from Git. cd into the DNS stuff. Set up my SSH agent so SSH can log into the remote system without a passphrase, and rsync the file over. This script is the push script that pushed out the DNS site to everything I needed. So, rsync the data to the DNS server in var tiny DNS data. For anyone who doesn't know TinyDNS, it's written by a guy named DJB. It is the most bizarre, twisted stuff, like all of his stuff is. It's great. I love it. If you understand it, you're probably a little twisted. So copy the file out. So he built a new server, and it wasn't getting updates. Didn't know why. So let's look at the new DNS server didn't have our TinyDNS data directory. When he tried to rsync the file out, it said there was no directory there. And he looked and there wasn't one. Okay. So he just missed a step in setting up the new one. When he tries rsyncing it to the current DNS server, then rsync said new file uploaded, merging local changes, compiling, and have a nice day. That is not the typical rsync output. Rsync means just copy a file out there. And in fact, when he went on to the production DNS server, there was also no var TinyDNS directory. So he copied a file to a directory that doesn't exist, and yet it seemed to work and seemed to say, have a nice day. Somebody was being clever. So trying to debug this thing, he's running his SSH to the existing DNS server, and blah, blah, blah. It's offering keys, it's sending environment, and here's that output saying that it's done something. This looks like shell output, not your file has transferred completely. Looking a little closer, apparently the remote had a forced command. What's a forced command? Well, when that key was used, instead of running the rsync command that was requested, it ran opt/bin/syncwa. I don't even know what syncwa stands for. So he would try to use rsync to copy a file, but instead it would run a script. What did that script do? Well, that script ran the rsync server to put the file in a totally different directory than the one you told it to go to. And then it ran this program called MakeDNS from, where's that? Bry's home directory. That sounds like production. What does Bry's home directory have? Well, it's looking through the various TinyDNS directories, because there might have been more than one based on IP address, going into those directories and running make. Look, more indirection. What's the make file look like? Well, it grabs that actual dropped off file, takes the local file, because there might be some local changes you want to integrate to, it sorts and concatenates those and runs a TinyDNS data program to compile them. This is a lot of confusion. So there was a lot of premature optimization. First of all, there was only one TinyDNS directory. So this whole let's run all of them was wasted time. There was never any data in data.local. So we were concatenating an empty file every time. That didn't save us any time. All of this work could have been replaced by this. Put the file in the directory where it belongs and run the TinyDNS data program. Instead, we had 5 layers of indirection and magic because somebody had too much time on his hands. In order for me to help figure out what was happening, actually took me 10 minutes. And I wrote it 6 months earlier. So if you're thinking you're clever, you probably are, and you're going to thwart yourself. I will skip this guy in order to go to any questions. Anyone have funny stories about stuff they've done that they would regret doing again?
I'm asking you, are you willing to cop any true data loss events?
I've definitely lost data, but I've actually always had backups that were sufficient. They're never like very last minute. It might have been a day old. I think the worst I've ever lost has been a day. But I've absolutely RM'd stuff by mistake, or used Ansible to update and wiped out all the things.
But you've always had a recovery.
I've always had a recovery of stuff, except for my house. You do everything great in prod, you do everything great at work, and your house is a friggin' mess. So yes, I've absolutely lost data in my house. So this is online for people who are taking notes. We're also suggested, if you have feedback that you want to give, there's a URL for it.